class, how are you doing today? That's great!
Alright, so the learning target today is to prove that two lines are parallel. Last class we determined if two lines were parallel. And so now we're going to prove it. The difference is determining is being able to figure out that it is. Proving is showing why. So it's a lot of explaining your answers, but there's a specific way to do it, and it's going to be using what's called a two-column proof. The scale for this lesson is a 3. You can prove that two lines are parallel. 2, you can prove that two lines are parallel, but you have trouble with the reasons for the step, the explaining why. 1, you can determine if two lines are parallel, but you can't write a proof. And 0, you cannot determine if two lines are parallel. Let's get started.
Alright, so now we're going to start off with the basics of a proof. The very basics is the way you set it up. So we're going to have statements and we're going to have reasons. So in this we have many lines. The number of lines will differ based on the proof. But there are 3 parts to a proof. The first part, the lines will differ based on how many you're given, but the first is the givens. These are the things you're given to start off with. At the beginning of the problem, you're going to be given some information. Maybe that lines are parallel, maybe that some angles are congruent to each other. These are your givens, so you always have to start out by stating those, and your reason will always be given. The next part of your proof is the main part of your proof. This is called the body. It's all but the last line of the proof, so the rest of the lines up to the end of the proof, not including the last one. This is where you'll say all of your information that will get you to your conclusion. You might need to say a few things before you can get there. You can't just start off with your given and then go directly to the conclusion. You have to say a few things in the middle, usually anyway. But usually you have to say a few things to get you to the conclusion. And then the last part is your conclusion. So this will be 2 things for us. It could be that you're saying that 2 lines are parallel. It could be that 2 angles are congruent or supplementary. Those are the types of things we're looking at. Either a relationship between the angles, congruent or supplementary, or that 2 lines are parallel. But the conclusion will always be what you're trying to prove. So at the beginning of your problem, you'll be given some givens and a prove. What you're trying to prove will always go in the last line. So whatever the prove is for the statement, that will go there for the statement. Alright, there are different types of reasons that you can put in your body and conclusion. So for these, I'm going to talk about 3 different types. First is properties. So these are specific properties that you can use with information from your givens or from the rest of your body to say other things in your proof. The next is definitions. These are specific things that we've talked about involving different figures and how those can be used to say things later on about angles and parallel lines. And the final is theorems. And for the parallel line proofs, these theorems will be the ones that we've been learning about the last couple classes, and I'll talk more about those in a little bit. Alright, so first talk about properties. First one we have is the reflexive property. The reflexive property is used to show something is congruent to itself, such as AB is congruent to AB. AB is congruent to itself. So this is actually one line segment congruent to itself. We won't be using this one too much for this one, but it's good to know under the properties. We will be using it in future lessons. The next property is the transitive property. This one is to get pairs of things that are congruent to each other to show other things are congruent to each other. For example, if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. So if angle 1 and angle 3 are both congruent to angle 2, that means they must be congruent to each other. So this one will often be used when you have multiple things congruent. You can figure out a pattern of all the congruence is related to each other. So 1 to 2, 2 to 3, that means 1 to 3. This one will be used a lot. Substitution property. This is to say something in an equation and substitute something that it's equal to or congruent to. For example, if angle 1 is congruent to angle 2, and angle 1 is plus angle 3 is 180 degrees, then angle 2 plus angle 3 is 180 degrees. So what we did was angle 1 and angle 2 are the same. They're congruent to each other. So what that means is in this equation here, instead of saying angle 1, we can say angle 2. So we plug in angle 2 for angle 1, and we get this equation. It's the same equation as before, just angle 2 instead of angle 1. So we substituted it in, hence why it's called the substitution property. Now you'll notice that these two, transitive and substitution, look very similar. Transitive is always used when you're dealing with only congruence, and substitution is always used when you're dealing with supplementary angles, such as this one where you're adding two angles and getting 180. So since they're supplementary, you'll deal with substitution instead of transitive. Next, we're going to talk about definitions. So the first definition we're going to talk about is a linear pair. And we've talked about a linear pair before. A linear pair is two adjacent angles that make a straight line. So here we have two angles, angle 1 and angle 2, and we have a line intersecting a straight line to make these two angles. So the two angles together form a straight line. So that means they're 180 degrees. So that means they're a linear pair. And if you remember, two angles that make a linear pair are supplementary. So if you ever see angles like this, those will always add to 180. And the next one I'm going to talk about is vertical angles. Again, we've talked about these before, but we're going to be using these a lot. Vertical angles are opposite angles that are formed from two intersecting lines. So remember, two intersecting lines, the opposite angles are vertical angles. So 1 and 2 are vertical angles. And remember, vertical angles are congruent. So they're always equal to each other. They're always the same. So linear pairs are always supplementary, vertical angles are always congruent.
Alright, and we're also going to talk about theorems. So, you've gotten all these theorems before, but I just want to talk about them again. So, we have the theorems that say if lines are parallel, then the different parallel line pairs are congruent or supplementary. And we also have the converse theorems, which say if the parallel line pairs are congruent or supplementary, then the lines are parallel. So in the first set of theorems, we are using these to show that angles are congruent or supplementary. So this is already knowing that the lines are parallel. We can only do this if we know the lines are parallel. And for the converse, this is us showing that the lines are parallel. So we already know that specific angles are congruent or supplementary, and we're using that information to prove that the lines are parallel. So one is used if you have parallel lines and you're trying to prove something about angles, and the other's used if you have information about angles and you're trying to prove that lines are parallel.
Alright, now for our first example. So we are given that angle 1 and angle 5 are supplementary, and we want to prove that L is parallel to M. So we're given that angle 1 and angle 5 are supplementary, and we want to prove that L, line L, is parallel to M, line M. So first thing we start off with is our statement, is our given. Angle 1 and angle 5 are supplementary, and feel free to abbreviate, it's perfectly fine. And the reason? Given. It was given to us. Alright, that's always the easy part, putting the given. Next, we need to find a way to prove that L is parallel to M. So we need some sort of parallel line pair. You'll notice 1 and 5 don't fit any of those. They're not any of the parallel line pairs. So let's see if we can find out any information that could tell us about parallel line pairs. Well, right away, I see 1 and 3 are vertical angles. So we can use that to show that 1 and 3 are congruent to each other. So angle 1 is congruent to angle 3. And we can say that because vertical angles are congruent. Now, we look at our previous statements. We've said that angle 1 and angle 5 are supplementary, and angle 1 is congruent to angle 3. We've said two things about angle 1. That means we can find a relationship between angle 3 and angle 5. So, in this statement, angle 1 and angle 5 are supplementary. We can replace or substitute angle 3 in for that, because angle 1 and angle 3 are the same. So we just rewrite this statement with angle 3 instead. Angle 3 and angle 5 are supplementary. And the reason? Well, we substituted angle 3 in for angle 1. So we use the substitution property. Now let's look at angle 3 and angle 5. Angle 3 and angle 5, we know that they're supplementary, and they're in between the lines we're trying to say are parallel, and they're on the same side of the transversal. So, those are same side interior angles. So using that information, we can say L is parallel to M. So we say, for our statement, L is parallel to M. And the reasoning goes back to the theorem. If same-side interior angles are supplementary, then lines are parallel. So this was a 4-step proof. We started out with our given, then we said something about an angle pair that we saw. We said that they were vertical angles, so that means they were congruent. Then we used two of our previous statements to make a third statement, and then we used that third statement to say that the lines were parallel. Alright, now for one more example. We are given that T is parallel to H, and we want to prove that angle 3 is congruent to angle 6. Again, for our statement, we start off with the given. T is parallel to H. Reason? Given. It was given to us. Now, let's try to say some other things about angles. So, angle 3 and angle 8 are corresponding angles. And since these lines are parallel, we can say that angle 3 is congruent to angle 8. And the reason for that? If lines are parallel, then corresponding angles are congruent. Now we can say angle 8 over here that we just found out something about, well, that's a vertical angle with 6. So those must be congruent. So we say angle 8 is congruent to angle 6, and the reason? Vertical angles are congruent. And now we've said two things about angles, and notice we said something about angle 8 in both of them. So that means we can make a relationship between 3 and 6. So since 3 and 6 were both congruent to 8, they must be congruent to each other. And the property that says that is the transitive property. So we started off with our given, that the lines were parallel. Then we said something about an angle pair, that 3 and 8 were congruent. And then using angle 8, we found a way to match it to angle 6, because they were vertical angles. And then since we said something about angle 8 in both, we could combine those to make one statement about 3 and 6 using the transitive property. Now, some of you may be watching and noticed an easier way to do this. So I did this out so you could see a lot of the method, because we'll have to do this for most of these. However, there is an easier way to do this one. There won't always be a way this easy, but for this one there was an easier one. And I think I'll show it to you. So, we wanted to prove angle 3 is congruent to angle 6. Well, angle 3 and angle 6, since we already know that t is parallel to h, 3 and 6 are alternate interior angles. So, angle 3 is congruent to angle 6. Why? If lines are parallel, then alternate interior angles are congruent. So we said the lines were parallel, so that means the alternate interior angles are congruent. And that was just a two-step proof. That's all you had to do for that one. Usually you'll have to do about a 4-step proof. Those are usually the average. Sometimes they can be longer, sometimes they can be shorter.
Alright, now time for the sponge. Given A is parallel to B, prove that the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. So write a 2-column proof that proves that. Alright, that's it for the lesson. Once again, please make sure to take notes on the entire lesson, submit it all to Google Classroom, and have a good night.